Hello, everyone, and welcome back to my YouTube channel. If you are new here, my name is Meshak, and this channel is all about sharing knowledge from whatever I'm learning. As I continue to explore exciting topics and acquire valuable skills, I'll be sharing them with you, hoping it inspires you and help you in your quest for knowledge. Okay, and don't forget to subscribe and hit that bell icon so you don't miss any of my future learning adventures. Let's dive right in. Today, I'll be sharing something I learned from Akshay Pachaar. It is on why pandas and numpy return different values of standard deviation. But before moving on, we need to check. Let's just talk about standard deviation a little. Okay, in very simple terms, standard deviation tells us how spread out or scattered the numbers in a data set, how they are. Okay, and it helps us understand the difference between a data point and the average or the mean or the average, anyone you choose to call it. Okay, where a larger standard deviation means that the data points are more spread out, while a smaller standard deviation means they are closer to the average. So let's check out what I'm talking about from this random data set. So I load the library Pandas and Numpy, and the weekly gaming hours is just the I just generate this randomly. Okay, then I'm converting this to a Pandas data frame, and I'll do the standard deviation. You see that I get 2.74 over here, and I'm going to convert that same list into a numpy array at the same time and check the standard deviation. You could see that I'm getting different values. This is 2.65 and this is 2.74. So why are we getting this kind of result? Now, it is because we're in Pandas considers the data set to be a sample of a larger population. It considers it to be a sample of a larger population. So to obtain an unbiased result, it uses n minus 1 instead of n as the divisor. Instead of n as the divisor. So if you check the formula for standard deviation, you will see that the denominator, that is the divisor, is in some cases it is n, where n assumes that it is the total population, while n minus 1 assumes that it is a sample of a larger population. So, but to get an unbiased result, the pandas uses n minus 1 instead of n. Okay, it tries to do what we call the Bezos correction in statistics, which is to help us have an unbiased outcome. So you can specify in your in this code either to have an unbiased result or to have a biased result. Okay, and that is what we call the Bezos correction in statistics. So in the case of numpy, there's no Bezos correction. There's no Bezos correction in numpy. So how do we now do it that we still get the same result? That is what we are going to be doing right now. All we just need to do is to add a parameter to both pandas. We also add it to the numpy standard deviation function, and that is DDOF, which we call the data degrees of freedom. Data degrees of freedom. It helps to specify if the process should be biased or unbiased. Where when you want it to be biased, it to be equals to 1, and when you want it to be unbiased, it will be equals to 0. So very easy. We just to specify it inside here, just a parameter that we add into the standard deviation. So we just say DDOF equals, in this case, we want it to be biased. We want it to be biased. We check it when it's biased and we check it when it's unbiased. So, and here too, we specify it. We just put a comma, okay, here, and we say DDOF, and we say equals 1. So if we run it again, this will give us 2.74 because it is biased, and here you can see we're able to get the same result. So, and if we want to get an unbiased result, we just put 0, and here we put 0, and we run it. You can see we get 2.65, and if you do that again here, you see that we get 2.659 and thereabout. So that's just it. So all you just need to do is to add the degrees of freedom parameter into your standard deviation, and you will get the same standard deviation result, no matter if you use pandas or you use numpy. So that's what I've just learned, and I'm glad I'm sharing that with you. So don't forget to subscribe, and you get other videos from what I'm learning in the future. So thank you very much. Bye.